Good morning, everyone. It's a Monday morning, so hopefully you're ready for the next week. Um, this week, we're in a chapter 4 where we're going to look at velocity and flow. And so I know a lot of you are new pump operators. These are things that you're just getting used to. And so maybe your idea is that just magically the water goes from the engine through the hose to the nozzle to the fire. But there's a whole lot more to it, as you've learned in the first 3 chapters. In fact, over these first 3 chapters, you've learned concepts that likely many seasoned fire engine operators apply, but they don't quite understand exactly how it works because they've never been instructed. And so, chapter 4 gets into velocity and flow, which is a really important topic in firefighting because understanding how water moves through a hose or a nozzle is critical and for effective fire suppression. We need to know not only how fast the water is traveling, but also how much water has actually been delivered to the fire. And so now on these new apparatus, you're going to have 2 different modes, a PSI mode on there, and then it's going to allow you to change for flow or for pressure, depending on what it is that you're going to use. And so let me break it down as simple as possible. Think about it this way: if you're using a garden hose to wash your car, the speed at which the water comes out matters, but so does the total amount of water that is reaching your car. If the pressure is too low, the water is just going to dribble out and nothing's going to happen. If the pressure is too high, it's going to spray everywhere and make a mess. The same concepts
Captain Robinson to the
apply
BC office.
to
Captain Robinson to the BC office.
firefighting, except on a much larger and a more critical scale. And so let's start with velocity. Velocity is simple. It's how fast the water moves through the hose or through the nozzle. You may not think about it much, but velocity plays a huge role in firefighting. Here's an example. Imagine you're holding your hose and you open the nozzle and the water comes out at a certain speed. That is velocity. If you squeeze the nozzle to make the opening smaller, the water comes out even faster. And that happens because the same amount of water is trying to get through a smaller space, so it has to speed up in order to get out. Well, the same principle applies when we use different hoses, different sizes in firefighting. A larger hose, a 2.5 or a 3 inch, allows water to move more smoothly, while a smaller opening forces it to move faster. So, what is it that you need on the fire ground? Well, it's really dependent upon the situation that you face. Do you need more water, or do you need pressure in reach and distance? That's why we have to be careful when choosing hoses and nozzles. I've always got it in the back of my head, big fire equals big water. So if I got a fully involved building or something of that nature, I want a 2.5 inch hose because I want to deliver a large amount of water. The pressure coming out of that isn't as important to me as the amount of water I can deliver quickly. Now, at the same time, if I am in a inside of a factory, if I am in a high rise, if I'm in an apartment building and I'm pushing down a hallway and I need distance because I need to be able to reach something farther, then I need pressure. I don't necessarily need more water because I don't want to flood the entire thing, but I need to reach the end of that hallway to where the fire is. And so you see there's differences. And so we have to be careful when we're choosing our hoses and our nozzles and we're getting the right velocity to control the fire effectively. There's a lot more to it than just pulling the line off the truck and opening the nozzle, especially when you get into the science involved. So let's think about how velocity changes with hose size. Now, if we take this concept a step further, the size of the hose of the nozzle operating directly affects the velocity. So think about a freeway, right? If a 4 lane highway suddenly narrows down to just 2 lanes, what happens to the cars? They either have to speed up to keep the flow going, or what normally happens is traffic gets backed up. And you think about maybe trying to come home from up north or something, on I-75, and about the time you get to the Bay City Saginaw area, it just completely jams up. The same thing happens with water in a hose. If you switch from a large diameter hose to a smaller one, the water has to move faster to get through. But on the other hand, if we open up a larger nozzle, the water slows down because it has more space to spread out. That's what happens with a 2.5 inch nozzle. You have more water coming through, so it's able to deliver the flow. An inch and 3/4, it delivers less water, but it's going through a smaller orifice, and so it's coming out faster. That's why in the top of a deck gun, you're going to have multiple tips because what is it that you're trying to accomplish? Size or distance or flow? Because as you take the tips off and you get down to the bigger nozzles, you're getting more water out instead of maybe distance. And the problem is you need to have the right hose for the job because too much velocity can create unnecessary turbulence, and too little means that the water won't reach the fire effectively. Excuse me. Like I said, it's Monday morning. So now that we've covered velocity, let's talk about flow. Flow is the actual volume of water that moves through a hose or a nozzle over time. This is what determines how much water is available to fight the fire. So think about a bucket of water. If you slowly tip the bucket, the water flows out at a steady rate. But if you just turn it upside down, the flow rate increases dramatically. So in firefighting, we need to control flow carefully to ensure that we have enough water reaching the fire without wasting it or without losing pressure. So how do flow and velocity work together? Well, a high velocity means that the water is moving fast, but that doesn't necessarily mean that a lot of water is coming out. So think about that. If you're on the fire ground, you're just telling somebody to pump it up, pump it up. That's not making more water go out. Water can only come out of an inch and 3/4 nozzle. That's so much because it's only so big, right? There's just no way. When you turn it up, all you're doing is trying to push it out faster. Um, on the other hand, a high flow rate means the large water is moving, but it may not be moving very fast. So here's an easy way to think about it. A fire hose with a small nozzle opening creates high velocity, but it creates a lower flow. It's great for reaching a fire at a distance, but it's not always ideal for large amounts of water. So think about your smoothbore nozzles. I've been around long enough to see the smoothbore nozzles come out and the combinations put in. And now it's interesting because of the hydrocarbons and the fires we're facing. I'm seeing the combination nozzles getting phased out and they're bringing the smooth bores back. The smooth bores are not going to deliver a lot of water. They're going to give you a lot of reach and a lot of intensity, a lot of velocity. A larger nozzle opening creates lower velocity but high flow. Perfect for large amounts of water quickly, but not as effective for reaching fires far away. So your 2.5s are going to throw a lot of water, but they're not going to get a lot of distance. So how is this practical to being on the fire ground? Well, in firefighting, we just don't pick a hose and start spraying water. We have to think about both velocity and flow. If the fire is close and we need to supply a lot of water to it, then a bigger nozzle is the right choice. Like I said, big fire, big water. But if the fire is farther away, or we need to maintain pressure over a long hose line, then a smaller nozzle with higher velocity may work better. This is also why pump operators have to carefully manage water pressure, because too much pressure can make it difficult for firefighters to control the hose, and too little pressure can make the water ineffective at knocking down that fire. So another real-world example would be using master streams versus hand lines. A master stream, right, which is basically the large water cannon mounted on top of the fire truck, and delivers high flow at a moderate velocity, which is really your best friend at large fires. I know that my time working in the city, I love deck guns. It's a little more difficult if you're in a rural atmosphere because you've got to be able to supply it. Um, but if you've got a big fire, the master stream is definitely the way to go. On the other hand, a hand line, which is a hose used by firefighters directly, balances flow and velocity for a more controlled attack. And so both of them have their place. And understanding the relationship between the velocity and the flow helps us decide which one to use. So the last thing that we need to think about is flow over time. Firefighting isn't just about how much water we can spray in a second. It's about maintaining a steady water supply for as long as a fire is burning. And this is the difficulty of being a pump operator. If you are in a city or an urban setting, connect to that fire hydrant, you should have really unlimited water. If not, and you're working on water tenders, well, now you've got a whole nother challenge because you've got to maintain enough water coming in to match what's going out. That's the reason that we measure flow in gallons per minute. It's not just about a quick burst of water, but it's a continuous stream that keeps the fire under control. If we don't calculate the flow properly, you could run out of water before it's extinguished. This is why hydrants, water sources, and pump operations are so critical. If we need a high flow rate, we have to make sure we have enough water available to sustain it. That's why fire departments plan ahead and practice these calculations and know the flow rates of their hydrants to ensure they have enough water to handle the emergency. So let's wrap this thing up. Here's my key summary and key takeaways, right? Here's the cliff notes. One, velocity is how fast water moves. The smaller the nozzle, the faster the water comes out. Two, flow is how much water is moving. Bigger hoses and nozzles allow more water to flow. All right. Number three, we need a balanced velocity and flow. Depending on the fire conditions, sometimes we need to speed it up, but sometimes we need more water and we need more volume. All right. Number four, managing your water supply is crucial. It's crucial. Firefighting is not just about spraying water, right? It is about making sure we have enough water to last us through the entire fire. And finally, pump operators and nozzle selections matter. Uh, we need to have the right combination of hose size, nozzle type, and pressure control, which makes all the difference in effective fire suppression. So, understanding these concepts will make you a more effective pump operator, and it'll make you a more effective firefighter, whether you're on the hose line or you're operating the pump. So, that's it. That is the overview of chapter 4. Your assignments are posted inside of the e-learning. And if you have any questions, make sure you send me an email or give me a call in my office. The line is there. And next week, we'll look into how we apply these concepts in real world um, fire scenarios. Thanks for your attention, and I will see you next week.